So what happens is sometimes we have vectors representing different quantities and direction that are added together. So if you had a vector representing the wind pointing in a certain direction with a certain speed, and then you add on top of that another gust with a specific speed and direction, the two would merge together and create a resultant vector. And so we like to see and observe these resultant vectors either graphically or using algebra when the vectors are written in component form. So for example, let's define u as vector written in component form where your x component is u1 and your y component is u2. So think of that as just like a coordinate point. This is the terminal point of your vector. And then you have a different vector, so think of the wind gust, and this one represents the terminal point of this vector. Together, let's see what happens when they blow in the same direction, so then the resultant vector that represents the force of the winds together would be represented by this new vector. So the nice thing is that when it's already in component form, it's really easy to do. You take the components that make up the x and you add them. So basically add the x components, so u1 plus v1, and then you would add the y components, so u2 plus v2. And the same thing would happen if you wanted the resultant vector to see what happens if if one went in one direction and the other one went in the other. Like it reversed direction. So in this case, we would say that the results would be, you would take u, if it's u minus v, where v reversed, then you would say u minus v1 would be the operation that you would perform. Same thing for the y components. You would take the u2 and then minus the v2. And these are the values of the component forms, the horizontal and the vertical, that you were given. Okay, scalar multiplication is what happens when the force of the speed of the vector that represents the wind doubles or triples. The nice thing is all you have to do is to double or triple or multiply that constant value to each one of the horizontal component and then the vertical component. So in this case, it's kind of like thinking about the k being your doubling or your tripling factor and distributing that to the x and distributing it to the y. So it would be k times x and then k times y. So down below here, for example number 5, if you were given vector v is written in component form, vector w is written in component form, perform this operation, v minus w. So what I'm going to do is write the component form, write the minus sign, and then the component form for w. So this represents me substituting in the component form for v, component form for w, and now doing a simple subtraction or combination of the two vectors. So 1 minus negative 4 is negative 3. Negative 2 minus 3 is negative 5. And so the new vector, the resultant vector, will have a component form of negative 3 comma negative 5. Now if we do b we notice, let's do our substitution. For problem b, you have a scalar, the 3, that's like tripling the size or the magnitude of the vector. So 3 times 1 comma negative 2, or tripling the component of each one of the horizontal component and the vertical component. 3 times v minus w, so 4 comma 3. So distribute the 3 to each one of these horizontal and vertical component, and we get 3 comma negative 6. And now we perform the operation that we see there. So that would be x minus this x, so 3 minus negative 4, and we get negative 1. Negative 6 minus 3, and we get negative 9.